Hey guys, in this video I'm going to be going over questions 15, 16, and 17 from the 2015 AMC12A. So question number 15 reads, what is the minimum number of digits to the right of the decimal point needed to express the fraction 1, 2, 3, 4, 5, 6, 7, 8, 9 over 2 to the 26 times 5 to the 4th as a decimal? So in this problem, the first thing we have to do is figure out how many 10s there are in the denominator. And by simplifying 2 to the 26 times 5 to the 4th, we get 2 to the 22nd times 2 to the 4th times 5 to the 4th, which is equal to 2 to the 22nd times 10 to the 4th. Since we have a 10 to the 4th in the denominator, we can move the decimal point of the numerator to the left by 4 places. So we're going to have 1, 2, 3, 4, 5, 0.6789 divided by 2 to the 22nd. And what we have to figure out now is what happens each time we divide this number by 2. And the key realization here is that every time we divide this number by 2, we're going to create one additional, or not one additional, but we're going to add 1 to the number of digits to the right of the decimal point. And to visualize that, we can use a smaller number, like 100.9. If we have 100.9 and divide it by 2, we're going to have 50.45. If we divide 50.45 by 2, we're going to have 25.225. So why does this work? Well, if you have the last digit as an odd number, then you're going to keep creating a 5 at the end, an additional 5 at the end. And the reason for this is if we have 9 divided by 2, we're going to have 4.5. If we have 7 divided by 2, we're going to have 3.5. If we have 5 divided by 2, we're going to have 2.5, etc., right? And since 5 itself is an odd number, we're going to create, we're just going to keep creating another digit each time we divide by 2. And if we go back to the original problem, since we already have 4 digits to the right of the decimal point, and we're dividing by 22 powers of 2, we're going to have these 4 plus the additional 22 digits to the right of the decimal point. And so we're going to end up with 22 plus 4 digits to the right of the decimal point, which is 26, and that's C. So this is question number 16. It reads tetrahedron ABCD as AB equals 5, AC equals 3, BC equals 4, BD equals 4, AD equals 3, and CD equals 12 over 5 root 2. What is the volume of the tetrahedron? So the first thing we have to do is obviously draw the diagram. So the first thing we draw is triangle ABC, which is a 3, 4, 5 right triangle, with AB being the hypotenuse. So we have ABC, AC is 3, BC is 4, and AB is 5. And we also have AD equals 3, BD equals 4, and since AB is 5, then we know that ABD is also a 3, 4, 5 right triangle. So if we have point D over here, we can just put it right there. And we know that AD is 3 and BD is 4. And CD is 12 over 5 root 2, so we can connect those and label. So the volume of this tetrahedron is just 1/3 base times height. The base is just the area of ABC, and the height is going to be the distance of the altitude from D to the plane containing A, B, and C. And so we can calculate B right now. B is just going to be 3 times 4 over 2, which is 6. So we have 1/3 6 times H. And the key realization to make in this problem is that D, the altitude of D from point D to the plane ABC is actually just the altitude of triangle ADB. And this is because the two planes are actually perpendicular to each other. Since we just have, this plane is basically just 2 congruent triangles that are perpendicular to each other. So to find this altitude, we know that, let's call it H. We know that 5H over 2 is going to be the area, but so is 4 times 3 over 2. So since the area is 6, we have 5H over 2 equals 6, and that means that H is going to be equal to 12 over 5. And if we substitute that in, we just have 1/3 times 6 times 12 over 5, This gives us 2 times 12 over 5, which is 24 over 5. And that's going to be C. Alright, so this is question number 17. It reads, 8 people are sitting around a circular table, each holding a fair coin. All 8 people flip their coins, and those who flip heads standing, while those who flip tails remain seated. What is the probability that no 2 adjacent people will stand? So the first thing we have to do is to count how many possible arrangements there are. Since we have 8 people and each person can either stand or sit, that's going to be 2 to the 8 total possibilities, and 2 to the 8 is 256. So 256 possibilities. And next, we're going to count the number of possibilities that actually satisfy the criteria that no 2 adjacent people stand. So to do this, we can count using cases. We can say case 1 is that nobody stands, and everyone flips tails. And there's obviously only one way that happens. Case 2 is that only one person stands. So if one person stands, obviously you can't have 2 adjacent people who stand. So each of the 8 people can stand, so there's 8 different possibilities. Case 3 is that only 2 people stand. If 2 people stand, we can use complementary counting to count how many ways that we can choose those 2 people and how many ways they can actually stand next to each other and subtract that. So there's 8 choose 2 ways to choose those 2 people, and since we can have 8 pairs that are adjacent, we're going to subtract 8. 8 choose 2 is 8 times 7 over 2, which is 28. 28 minus 8 is 20. Case 4 is the hardest one, and it's that it's the case where 3 people stand. If 3 people stand, we can use a similar method and say we're going to choose 3 people and we're going to use complementary counting. So in case 4, there's actually 2 subcases. The first subcase is if all those 3 people who stand are adjacent to each other. And there's 8 possibilities because you can have you can have 8 adjacent trios. And the second subcase is if 2 people are standing next to each other and the other person is standing somewhere else that is not adjacent to either person. So we can draw a diagram in order to find how many cases there are for that. So there are 8 ways we can choose the 2 adjacent people, and there's 1, 2, 3, 4 ways to choose the other person. So there's 8 times 4 possibilities. 8 choose 3 is 8 times 7 times 6 over 3 times 2, which is 56. 56 minus 8 is 48. 48 minus 8 times 4 is 16. Case 5 is is where 4 people are standing, and there's only 2 possibilities for this because you can have 8, 3, 4, 6 standing, or you can have 1, 7, 1, 7, 5, 3 standing. So there's only 2 cases for this. If we add all these up, we're going to have 9, 20, 29. 29 plus 16 is 45. 45 plus 2 is 47. So our answer is going to be 47 over 256. And if we look at the answer choices, that's A.